Okay, now we're going to talk about some matrix operations. So as usual, make sure you read the notes that lead up to these operations, and I will just get straight to it. The first operations I want to talk to you about is adding or subtracting matrices. So you can actually add two matrices or you can subtract them as long as both matrices are the same size. If they're not the same size, then you have to say the operation is undefined. It can't be done. So let's just look at the second one. This first one just kind of shows you what you're supposed to be doing, but it's really probably the simplest thing you'll ever do in this course is add two matrices. So notice that this is a 3 by 2. This is a 3 by 2. This is a 3 by 2. And since they're both 3 by 2 matrices, we can add them together. Now all I have to do is take the row 1 column 1 element here and add it to the row 1 column 1 element here. And so -2 plus -1 is -3. And then I take the row 1 column 2 element here and add it to the row 1 column 2 element here. 3 plus 2 gives me 5. And you just continue that process. 0 plus -3 is -3. 1 plus 2 is 3. 2 plus 5 is 7. And then -1 plus -2 is -3. And that's all there is to it. Now here, this matrix is a 3 by 2. And this matrix here is a 2 by 2. Remember, they have to be exactly the same size in order to add the two matrices. So you can't add or subtract these two matrices because they're not the same size. Subtraction is just a form of addition. So if you wanted to subtract two matrices, like this matrix minus this matrix, you would just do the same thing. 3 minus 5. 3 minus 5 is -2. Minus 1 minus -3, well, remember that changes the sign, so it's -1 plus 3, which is 2. And then here you have 2 minus 4, which is -2. And then you have 0 minus -1, which is actually 0 plus 1, which gives you 1. So that's the result of that. If we want to subtract these two, you get -2 minus -1, so that's -2 plus 1, which is -1. 3 minus 2 is 1. 0 minus -3 is 3. 1 minus 2 is -1. 2 minus 5 is -3. And -1 minus -2 is -1 plus 2, which is 1. And of course, you can't subtract these either, so because they're different sizes. Another operation you can do is multiply a matrix by a real number. So if I wanted to multiply a matrix by a real number, like if I wanted to multiply 5 times this matrix, all you do is just multiply every entry by 5. So 5 times -1 is -5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. Not sure where that came from, but 5 times 3 is 15. Okay, same thing here. -3 times -2 would be 6. -3 times 3 would be -9. -3 times 0 is 0. -3 times 1 is -3. -3 times 2 is -6. -3 times -1 is 3. Now you can combine these two operations. Like if you wanted to, you could do an operation where you add or subtract a linear combination of two matrices. So I could say 2 times this matrix minus 4 times this matrix. And as long as 2 times this matrix and 4 times this matrix are the same size, which they will be, then you can do that operation. So first I'll multiply everything here by 2, and so we already know how to do that, so let's just say I did. So I multiply everything here by 2 and I get this matrix. And then I'm going to multiply everything here by 4. Not negative 4. I'm going to multiply by 4 because I'm going to leave the minus on the outside. Okay, so multiply everything by 4. And then I'm going to subtract. So minus 4 minus negative 4, that's minus 4 plus 4, which is 0. And then 6 minus 8 is negative 2. And then 0 minus negative 12 is 0 plus 12, which is 12. And then 2 minus 8 is negative 6. And then 4 minus 20 is negative 16. And then minus 2 minus negative 8 is minus 2 plus 8, which is 6. And that's how you do that. Now there's some practice problems down here that you can practice on if you want to. But I'm going to go ahead and move on to matrix multiplication. In order to multiply two matrices together, the first thing you have to learn how to do is how do you multiply a row matrix by a column matrix here. Okay, this is very simple to do. What you're going to do is you're going to multiply the first entry in the row by the first entry in the column, 2 times 3. Then you're going to add that to the second entry in the row by the second entry in the column. So you're going to add it to negative 3 times 5. And then you're going to add to that the third entry times the third entry. And that's going to be negative 1 times negative 2. So you just add those three together. 6 plus negative 15 is negative 9, and then negative 9 plus 2 is negative 7. And you're just going to get a 1 by 1 matrix. Now, notice that the first matrix had 3 columns, and the second matrix had 3 rows. That's important because when you put their sizes together, the order that we're going to multiply them, then you can see that you have the same number of rows, same number of columns in the first matrix as you have rows in the second. And that has to be true, otherwise you couldn't multiply this row by this column. Okay, so take a look over here. We have 4 columns in this matrix, and we have 4 rows in this matrix, so we can certainly multiply them together. We take 1 times negative 5, then plus negative 2 times 6, then plus 3 times 7, then plus negative 4 times negative 8. And then you just do the arithmetic here, and you get minus 5, minus 12, plus 21, minus 32. And if I did my arithmetic right, that comes out to negative 28. And again, you have to have the same number of columns in the first matrix as you have rows in the second, or this operation is, if not, this operation is undefined. Okay, think of this. This is an example of multiplying two matrices together. Think of this as your instruction manual, because you don't really have to do this every time you multiply matrices together. But here's how it works. If you want to multiply this matrix here by this matrix, first of all, let's see if it's allowed. This has 2 rows and 3 columns. This has 3 rows and 3 columns. Let's look at the inside numbers and make sure they match. That's what's important. Since they do match, we're allowed to do this. So now let's multiply. Here's how we do it. Take the first row from the first matrix and multiply it by each one of these columns. So multiply it by the first column, multiply it by the second column, multiply it by the third column. And you can see here is the first product, here is the second product, and here is the third product. And since you already know how to multiply a row by a column, I shouldn't really have to go through this too much, but you would say 1 times 2 plus negative 1 times negative 1, negative 2 times negative 1 plus negative 1 times 1, and then add those up and you get 3. Then here you say 1 times 0 plus negative 2 times 3 plus negative 1 times negative 3, and add those up and get negative 3. And then here you say 1 times negative 5, negative 2 times negative 2, negative 1 times 4, add those up and you get negative 5. Well, once you finish that, then you take go to the first matrix, drop down to the second row, and take that second row and multiply it by each one of these columns. So here I'm going to multiply it by the first column, here I'm multiplying it by the second column, and here I'm multiplying it by the third column. So for this product I have 0 times 2 plus 3 times negative 1 plus 2 times 1, and add that up and I get negative 1. Here I have 0 times 0 plus 3 times 3 plus 2 times negative 3, add that up and I get 3. And then here I have 0 times negative 5 plus 3 times negative 2 plus 2 times 4, add those three products up and I get 2. And notice that the result is a 2 by 3 matrix. Not that it really tells us a whole lot, but if you look at the outside numbers here, the outside numbers tell you the size of the resulting matrix. Notice if I reverse the order of the multiplication, I can't do it. It's undefined. See, because here I have 3 columns, but on the other matrix I only have 2 rows. So if I tried to multiply this row by one of these columns, I wouldn't have enough elements in this column in order to do that. So that would be an undefined operation. You can see if you multiply these two matrices in one direction, A times B, and then multiply them in the other direction, notice you get two totally different matrices. So even if you can multiply two matrices in both directions, you're not necessarily going to get the same thing. So that shows you that matrix multiplication is not commutative. A times B does not equal B times A. I'm just going to finish up this section. Pause the video and read this, but basically this is just a simple application. You have two items here and you have two departments, assembly and finishing, and the labor hours are 5 hours and 1.5 hours for assembly and finishing for item A, 3 hours and 1 hour for item B. And then you have two locations, one in Arkansas, one in Texas, and this is what you pay for wages: $12 an hour in Arkansas, $13 an hour in Texas for assembly, $7 in Arkansas, and $8 an hour in Texas for finishing. Well, if you multiply W times L, you'll get a result, but it really doesn't make much sense. But if you reverse it and do L times W, then it actually makes sense, because when you get these results, when you multiply this row with this column, what it does is you get the assembly hours, you get items A assembly hours times the hourly assembly pay in Arkansas, so that would be the 5 times 12, and then plus item A finishing hours. Let's see what else. Let's see, 5 times 12, and then 1.5 times 7 is the item A finishing hours times the hourly finishing pay in Arkansas. So basically you get what it costs to make item A in Arkansas. And then if you do this row with the second column, you'll get what it costs to make item A in Texas. And then if you do this row with this column, you get what it costs to manufacture item B in Arkansas. And then this row with this column is what item B in Texas. Okay, read this one, but notice that if you take this example and you take dealer 1 and the number of cars sold, dealer 2 the number of cars sold, and then multiply them by the revenue per automobile, you'll actually get the total revenue for dealer 1 and the total revenue for dealer 2. Now at first that may not make that big of a deal to put it in matrix form when we could have just done it with a calculator, but let's suppose that you had lots of dealers. Scratch that right there. This should, like, this will be dealer 1, dealer 2, dealer 3, dealer 4, dealer 5, and then you've got all these cars and you've got all of these prices here, and so you can see that on a larger scale it might make more sense to use a matrix. You can read the rest of them down there below.